This is CCNA 200-301 Day 2, covering network topologies and architectures. So let's get into it. So, network architectures. So there's many types of network architectures, and these are the ones that you'll need to know about for the CCNA. It's a two-tier, three-tier, and spine leaf. Network architectures refer to the design and structure of a computer network. They define how different network devices and services are arranged and interact to facilitate communication and data exchange. So let's begin with the three-tier architecture. So here it is. Just looking at the image first, you get the core layer, then you got the distribution layer, then you got the access layer, and underneath it, end users. So this is the access layer where the end users will access all the switches that are basically at the end, where they're like the access, right, to remaining. And these are kind of the distribution layer, which choose which place is going to go to. But let's get into it. So the three-tier, this model divides the network into three layers. The core layer. So the job of the core layer is to handle and transport huge amounts of data quickly, and make sure it's reliable, and it makes it allow it to connect multiple end networks together. So it's one job is just to transfer huge amounts of data. And then the distribution layer is the middleman between the core and access layer, and it makes sure that the local traffic is locked into its local networks. So like I was saying, it's if it's say this is a network, then it's gonna stay within that network, so that if it shoots there, it comes back into that network, is what I mean. And the access layer gives access points for the hosts to connect to the network, so like those end devices. And that's the three-tier architecture for you. So here are the jobs of three-tier network. These are the common jobs. Of course, high-speed data transfer and reliability is the job of the core layer. And the distribution layer's job is routing, policy implementation, redundancy, broadcast domain control, inter-VLAN routing. And the access layer is device connectivity, VLAN membership, so it's the management of VLANs, right? To make sure that VLAN 1 and which ports are in VLAN 1. we're gonna cover VLANs later, but yeah. And then port security, to make sure the port's secure, and quality of service, which we'll cover soon, and power over Ethernet, which you learned in last video. That's the whole purpose of access layer, so it gives the power to the phone or something. Alright, next up, two-tier architecture. So two-tier architecture is just a three-tier collapsed. It's also known as a collapsed core architecture. So it's exactly the same as three-tier, but three-tier architecture costs money. So they just collapse these two layers into one, and it's more for I'll cover it here. So what happens is that the functions of the core and distribution layer are joined together as one layer, which makes the network design simpler. So here it is. See right there, before there's three layers, now it's just switches here, and the access layer switches. So it's basically the smaller networks, like I was saying, where simplicity and cost effectiveness is important. So you'll see this in small businesses and things like that, where they don't have as much money to spend out on three-tier architecture, so they choose two-tier, which is simpler, but it works and does the job. Alright, so the jobs of each tier is basically the same. Access, it stays the same as what it is in three-tier, which is device connectivity, VLAN membership, port security, quality of service, and power over Ethernet. And the collapsed core layer is just a combination of what the distribution functions are and the core layer. So it leaves you with high-speed data transfer and reliability, but then it also adds on with routing, policy implementation, redundancy, broadcast domain control, and inter-VLAN routing. That's it for those two. Now, this is the newest one. It's the modern one. It's spine and leaf architecture, right? So it says right here, spine and leaf architecture is a newer architecture and is mainly used in data centers. This architecture is specifically tailored to handle high volume, low latency traffic, making it well suited for environments with significant east-west. So it's server to server traffic. So like this one to this one, right? And it's great. So yeah, it's just another architecture of how they communicate. So if say this server is like, I want to talk to this guy, then it will go here. And each one of these switches are connected to each of these. So it's redundant. Redundant means where it's like it's not going to shut down if one of these collapse. So say like this link broke, but this server still wants to talk to this server. This link broke, but now I can just talk out of this link or this link, which would allow it to like not fail, and it has more redundancy basically for failures. Like if something fails, there's a backup, is what redundancy is. And so that's what's a really good benefit of having each one of these connect to something else, all of them. So unless all three spine switches break and fail, you should be able to transmit data, is the end point, because they're all connected. WANs. So WAN, wide area network, is a network that extends over a large geographical area. They're like the biggest network, right? WANs are often established by service providers to connect different smaller networks, such as local area networks and metropolitan area networks, so LANs and MANs, ensuring that they can commute with each other or communicate with each other regardless of physical location. So the WAN's job is just to connect multiple LANs and MANs, and it just allows communication and data exchange between the different locations. See, such as LAN, 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 and then connected all together it's called WAN. That's about it. So basically a LAN, local area network, like if you're curious on what a LAN is it's a network that connects computers and other devices within a relatively small geographic area, such as a single building, a campus, or a home. And then a MAN, which is a metropolitan area network. So this is just overview if you don't know what builds up a WAN, of like what we talked about in the previous slideshow. A MAN, which is a metropolitan area network, is a type of network that spans a larger geographic area than a local area network, but is smaller than a wide area network. So it's like big, but it's not like crazy, right? Like not like a WAN. And it's like city, like a MAN, like New York City would probably have a MAN, which is just a network that spans a large geographic area on like some street or something. And it would cover a city or a large campus, and it can extend up to several tens of kilometers, connecting multiple LANs within a metropolitan area, which means city area. So it's bigger, but it's not as big as a WAN, and then LAN is like small, as in like a house or something. So now moving on to SOHO, small office, home office. So basically you just need to look at the key point, that is small office or home office, which means they have different needs and like considerations that would be different from say big business or enterprise. So it's just small, reliable, cost effective, and easy to manage connectivity for like a small amount of users and devices. So it's just a mini network, I guess. Yeah, it's just reliable, cost-effective, simplicity. It's all about simplicity because you don't need all the fanciness if it's not a huge huge network, like needed demand, like servers and whatever. On-premise and cloud. This is a big one on the case that like cloud is a new huge rage, which is everything is sourced through the internet. But on-premise refers to hardware and software that is installed and run on computers and servers located within the physical premises of office. So imagine like you're at Microsoft's office, and then that would have its own servers. That'd be on-premise. But say you're at like Dodo's networking lab facility in like Texas, and we don't have the money to afford on-premise servers and stuff because it's very expensive. So we would go through the cloud and basically rent out the space that other people would provide, like Amazon Web Services and stuff like that. They would give you server space. So it's like the delivery of computer services, which is servers, storage, database, networking software over the internet or like the cloud. So like other people have stations where you can borrow their resources for money. That's if you like don't have the money to set up your own on-premise stuff, because it gets very expensive if you have on-premise like hardware on your own computers in the office. Alright, so that was it for that. Now let's cover practice questions. Remember I said in last episode, practice questions are key to passing the CCNA. You need to do a lot of them, and I would, in my last video I put in the description, I think I'll put it in this one, it's called Pass 'em All. It was great. It's free. You just do the diagnostics again and again, and it will tell you what you did wrong and like what the actual answer is with a huge description. If you take so many of them, you're actually just going to basically, there's only a limited amount of questions that they could probably give you on the CCNA. So you'll see very similar questions, but it's not like an exam dump, so it's not illegal, but it's like the similar basis of questions that you should just be flying through the CCNA with no issue, because you're like, oh, I already know this and whatnot. So, but I made my own practice questions for this video of what you learned. So let's go through these. Pause the video whenever you want to answer them, and then I'll reveal the answers and see how many you got right, how many you got wrong, and see what you need to work on, and go back in the video if you don't understand something. Alright, so practice question 1. What network architecture is newer and used particularly in data centers? A, 2-tier, B, LAN, C, 3-tier, D, spine and leaf, or E, MAN? Okay, the answer is D, spine and leaf. So remember that it was the architecture that is newer and mainly used in data centers. Alright, practice question 2. What layer gets collapsed in the 2-tier architecture? Is it the core, the access, or the distribution? I want you to choose. Okay, the answer is C, distribution. Because remember, there's core and access in the 2-tier architecture, and the distribution gets collapsed into the core, so that's its efficiency and that's what it is. Practice question 3. What is a MAN? Metropolitan Area Network. A, it's a network that connects computers and other devices within a relatively small geographic area. B, it's a network bigger than a LAN and usually used to connect LANs in a city. Or C, huge reach made up of LANs. The answer is B, because it's in a city, but it's bigger than a LAN, and it's metropolitan. When you think of metro, think of like the New York subway, Metro or something, right? That's like city theme. So then that would make you remember it better, if that helps. So Metropolitan Area Network. Yep. And I think that is it. Thank you so much for watching. If you want to support this series, please like and comment and subscribe. And a link to my Patreon is in the description below if you want to drop a donation of appreciation for the CCNA course. Thank you so much for watching. I'm glad you're enjoying the series. Tell me if you are. Leave any suggestions in the comments. And also, if you need private tutoring or anything like that, it's in the description of my channel is my WhatsApp number, and you can message me for rates. Thank you so much for watching and have a great day.